So in Chem 111, you learned about intermolecular attractions. And intermolecular attractions, there are two basic types. What are they? Ionic and covalent are the two types of intramolecular attractions that actually form bonds, the two types of bonds.
IMFs?
Yes, IMFs, intermolecular forces. And what are they? What types are they? Anybody? Polar molecules have a particular type of force, and it's called what? Maybe they just called it polar when you learned. Hydrogen bonds are an extreme type of this force that polar molecules exhibit. It's called dipole-dipole forces. Okay, dipole-dipole forces or dipole forces. Does that sound familiar to everybody? That's what polar molecules have. And hydrogen bond is a intense type of a dipole force where you actually get a physical bond. And what criteria do you have to have in place for a hydrogen bond to form? A hydroxyl or? Hydrogen is bonded to fluorine, oxygen, or nitrogen, the three most electronegative elements. And they have to actually be bonded to the hydrogen in the molecule. And a hydroxyl group is the most common example of that, right? And what is the type of force that nonpolar molecules have? Well, actually all molecules have them, but it's the only force that exists in nonpolar molecules. What is that called? London or dispersion or van der Waals forces. Okay, and those are very weak. So when we look at things mixing together, we think that we have to break the attractions that the solvent has for itself, break the attractions the solute has for itself, move the molecules apart, then intersperse them and let them mix. Now, if we try and mix two liquids, then we make a liquid-liquid solution. So we've always say in chemistry, the old chemists will say, well, like dissolves like. Things that are alike dissolve each other. So things that are polar will dissolve in each other. Things that are nonpolar will dissolve in each other. And things that are polar will not generally dissolve or be miscible with things that are nonpolar. So if we have two liquids, A and B, then we have the molecules of B have to move apart to make room for the molecules of A to mix in. When we look at ethanol and water, these are very miscible. Okay, here's water. Remember, the bond angle is what?
180.
Not 180. Looks like it if you draw it in a straight line.
Like 104.
Yeah.
Bend.
Okay. Start at 109.5, the tetrahedron, about a 2-degree bond angle depression for each lone pair, about 105.5 about. Right? Yes? You remember hearing that? You're not giving me a look of recognition. Okay, yes, he does.
Do you have to know the names? Or no? Just the number.
The names of what? Water?
No, I mean like the bonding.
Oh, you mean the shape? Well, that's something you were tested on in Chem 111. You're not going to be tested on it in here, but you better know that water is polar because it's bent, because it has two lone pair, because it has a dipole across. So you have to know that, but no. We're not going to retest on Chem 111 stuff. If you're going on to organic chemistry, that chapter on molecular shape is the one chapter that will really serve you well in organic chemistry. Or if you don't remember it, it will really stick you because you won't understand anything going on in organic because you won't understand what shape the molecules are, so you won't understand how they attack each other. Okay, so you really need to know that for organic, not so much for this. Okay, so we have water, and then we have ethanol. Eth means how many carbons? 2. So here's ethanol, and it also has the hydroxyl group. So these can actually form a hydrogen bond between the water and the ethanol. So they are very attracted to each other, and they will dissolve in all proportions. Okay, things like hexane. Hex means what? 6. Okay, things like hexane or benzene do not dissolve in water because they are very nonpolar, and we don't use benzene in the laboratory anymore anyway. You'll talk a lot about that in organic. Benzene is 6 carbons in a ring, has alternating double and single bonds. We say that it's aromatic, but we are not allowed to use benzene in the laboratory in chemistry in most undergraduate classes anymore because it has been shown in the last 20 years or so to be a class 1 carcinogen. When I was a student, we used benzene all the time. We'd just slop it around in rooms where there were no hoods. We didn't wear gloves or anything. It was a different world. And it's very fragrant. And I can remember when I was doing my undergraduate research, my lab mate was refluxing flaxseed with benzene to extract some of the components from the flaxseed for a research project. And I'd walk in the morning and these stills would be going, and I'd just stand there because it smells really good. It's very aromatic. And now you're not allowed to have it in the lab because it causes cancer, right? Class 1 carcinogen. But, I'm fine. So anyway. It's a different world now, than you're not allowed to have mercury. We used to play with mercury when I was a kid. We'd break thermometers on purpose and collect the mercury and play with it because it's really cool. Okay, so these are different types of molecules, so they don't dissolve in each other. One of my favorites is 2-propanol. 2-propanol, or also called isopropanol. You know this from your everyday life. Where is it in your house, probably? Isopropanol? Isopropyl alcohol, rubbing alcohol. Where is it in your house? In the bathroom, right? Everybody keeps it in the bathroom for cleaning things, disinfecting things, especially if you're shooting up anything, right? Yeah, well, you kind of clean it up. And 2-propanol is interesting for us in chemistry. It's really useful. Prop means how many carbons? 3. And the 2-propanol means that the alcohol, the hydroxyl group, is on the second carbon. And so if you look at this and you think about the shapes, the fact that carbon is going to have 4 things attached to it, so it's basically tetrahedral. So we get these bond angles in here are 109.5. And then this gets changed a little bit. So this actually sort of folds back on itself. It causes a nonpolar area of the molecule. And then this is a polar area of the molecule. So the polar end allows this to dissolve in water. The isopropanol you have at home in the medicine cabinet is 70% isopropanol. And this part of the molecule is polar, so it will dissolve in polar things. So isopropanol can swing both ways, go in polar solvents or nonpolar solvents. And that's really useful when you're cleaning up nasty messes. Or in chemistry, if you have glassware that was used for a nonpolar material, it kind of leaves a greasy film on it. You can rinse it in isopropanol, and that'll get the greasy residue out. And then you can wash it with soap and water because the water will dissolve the isopropanol. Or if you have a pump that you're trying to change solvents, isopropanol is a really nice way to change. If you were using a pump to pump liquids that were nonpolar, you can pump isopropanol, and then you can put polar solvents in there. It's very handy, and it's really useful at home. I mean, I keep it all over my house. I have some in the kitchen because if you spill like Mazola oil on the floor, isopropanol will clean that up really quickly, and then you can wash the area with soap and water to get rid of the isopropanol. So really handy. It also works nicely in the laundry room. It dissolves and will remove a lot of things like ballpoint ink pen. Isopropanol takes that out nicely, better than some of the other stain fighters that you buy, and it's cheaper too. So everybody should have isopropanol, hydrogen peroxide, and nail polish remover in their house, because nail polish remover, the cheapest, nastiest stuff you can find that you never want to put on your nails, but it's really good for removing other stuff because it has acetone in it. Acetone will remove Sharpie marks. It takes Sharpies out of your clothing or off of the walls if your children draw on the wall, or if your dog chews up a Sharpie on your carpeting, which my dog did. it'll take that out too. The isopropanol will actually remove that from the carpeting. But always check it to make sure the carpet's colored fast first. But see, you can learn a lot in chemistry besides just stuff to pass the test, okay? That won't be on the test. But it'll serve you well in life. Okay, when we have a solid liquid solution, then you have solvation taking place where the solid molecules actually completely surround the solute molecules, and we have hydration. If it's an aqueous solution, we call it solvation. If it's not water, then it's something else. So when we think about this, we look at the mechanism for hydration of an ionic material.